And then share our screen. Okay, so yesterday we already started to discuss pandas, and we discussed series, is it? Series is labeled, is it labeled? Oh, let me go back to waiting room. Okay, I need to admit all. Okay, so the difference between series and generally like list or array one-dimensional is it has a label, is it? So labeled, okay. And we also learned data frame. And data frame supports multi-dimension, is it? And you can also specify a label for each dimension, or we call axis, is it? So we already learned. And then we also learn how to do slicing, is it? We call all cross-section selection. Is it? And there are multiple ways, is it? You can call that lock, is it? And we also discuss iLock, is it? And the difference between these two is iLock supports position, is it? And for the lock, it can use label, okay, quite useful, is it? And we can do single item selection, is it? You can also do slicing, is it? Yeah, so that's the general idea. Then let's see. Oh, and also the at, is it? And I at, the difference between that, it's faster, okay. And I remember in NumPy, we also kind of learned like you can also do Boolean selection, is it? So here to discuss Boolean indexing, is it? And here the example shows. So this is DF is the data frame. I remember it's a random number, is it? And it has 4 columns, and the axis 0, the label is the time series, is it? And it has 6 rows. So over here is, you can see it just to do the df dot A, is it dot A? The dot A is specify column A, is it? So on column A, if the item is greater than 0, is it? Then you are going to pick that item. So it's based on column A, is it? And the result is shown like this. So this just shows we can also use Boolean indexing, is it? Because previously with what we discussed is you either use label, is it? Or you use the position, is it? But over here, it's some Boolean condition. You can also do selection. This is quite useful, okay. That's this example. And the next one, it just shows everything, is it? Not just that specific column greater than 0. It's all of the items. Is it any item that is greater than 0, then you are going to select, is it? Then in this case, some of them not 0, then not less than 0, then it will show as the net values. Okay, so this is regarding Boolean indexing. And then what next show is we can also use this method to do filtering. It's called is-in method. Okay, is-in method. And here it just copy. So df2 is a copy, and we know this is a deep copy, not the shallow copy, is it? And then you add a new column called E. So column E is newly added. Then we can do this. Is that you provide a list. And what over here it shows is for this specific column, is it? And if it has 2 and 4, is it? If it has these 2 values, you're going to pick them out. So then did you see? Yeah, it does just pick out which the column E has 2 or 4 values. Then it pick out of the records. Okay, so that's about this is in method can also be used for filtering. Okay, and indexing, we use Boolean indexing. It's a quite a good way also do a selection. And over here, what it shows is you can also add some new column is it automatically, and it says aligns data is it by the index. Okay, by the index. So let's see. The S1 is a series. This is a series, and the series value. So this is a one-dimensional value. It's from this list. And this is to specify the index. Is it the index is time? Is it it's the date range? Is it and selects 6 day? Is it so? This is a series. It's generated. Okay, and like over here it shows the frequency is day. Is it? And then on the previous data frame, DF, is it that DF data frame, it has A, B, C, D, E. Is there 5 columns, and it has 6 rows. Is this with time? And now it adds the new column F. Is it the new column F? What the data is going to have? It's going to have from this series. Is it? So that's over here it shows. And here it shows align, then it's going to align the data by index. Is it? And for this one, the index start at what? January the 2nd. Is it January the 2nd? So here, then let's move on to take a look. The previous one, the DF started at January the 1st, is it? And this S1 started at January 2nd, is it? So that's why when you add this new column, is it? And F, it only the S1 only contains from 1 to 5, but from January 2nd, is it? So the first one doesn't have the value, is it? But it will aligned, is it? We can see it's aligned with the original DF's first dimension axis, is it? And the one that it doesn't have value, it will automatically fill with a nav value. Okay, so here is, if you have a series and you specify the index, and the index have some overlapping with the existing data frame, it will automatically do the alignment. Okay. And here it says we can also set a value by label. Basically, this we already know, is it? And over here, it regarding the data frame, and use at. And we know at is faster, is it? And it specify which dates. This is the first one. And the column is from column A, is it? So overall, both of this is label. That's the benefit of Pandas, is it supports labeled index, is it? Not just purely depend on the position, okay? So over here, for the first dimension, second dimension, for both dimension, we use label to pick the item, is it? So we are going to set the item to a new value. That's what it does, okay? You can also use position, is it, like over here? And then if you use position, you can use I at, is it? And the first dimension, second dimension, that's this item, is it? Okay, so that's regarding using label and position, okay? And what next? Let's see, set assign with NumPy array, is it? So it's still on that data frame DF, okay? And here we have the NumPy array, is it? And it has it's based on the length of data frame, is it? That's 6. DF, the length is 6, is it? And here we have a single value list with 5, is it? And I believe you still remember this sign. What does it mean in Python? Okay, so you all know this, what it means in Python. Is that this is for what? For repeat. Is it? It's not to multiply, okay? So it's repeat this 5, is this 6 times, okay, 6 times. So that's why we have 5 values, is it 5? And what it does is it use the dot log, is it? And the first dimension is everything, slicing. Second dimension picked the D column, is it? And with the D column, what it does, it's going to assign this new value. Okay, that's what it does for this one. And we can also do using Boolean indexing, is it? And here the df2 is a deep copy of the df, is it? And what it does is, whoever the item is greater than 0, is it? I'm going to negate it. That's what it means. So it negate all, so you will see all of the negative values, is it? So yeah, you can also borrow the Boolean indexing to do some operations. So that's what this part shows. Okay, then next, let's see, how do we deal with missing data? Okay, and then later on when we learn machine learning, we will also need to deal with this. So missing data, and let's see over here. So here it's working on that data frame, is it? And the data frame, what we do is we also do re-indexing, is it? And the index is from dates 0 to 4, is it? And the column from that original list, A, B, C, D, F, is it? And the plus column E, okay? So that's what this part does. And what else then it selects is select from, so this is slicing, is it? Slicing. And column E, is it for column E? And from the first date, is it, to the second date, is it first and second date, and then it reassign the value to what? To 1. Okay, so you can do something like this. So this is not new. And the missing data, yeah. So here, let's see, how do we do with missing data? So missing data, we can do drop NA. Okay, so we can drop nav values. And you can specify how you are going to drop. Okay, how you're going to drop. And in this case, if there is any, okay, then you're going to drop. Then after that, we only have this single row left, okay? And a lot of time, we are not going to do drop. We are going to do some filling the missing data. Then you can do fill NA, okay, fill NA. So in this case, is if that value is nav, as it's going to fill with 100. So that's how you see those 100 comes. And a lot of time in machine learning, you can pick like average, like mean value to do filling. Okay, so that's later on topic. And you can also do the is NA check so that you know, okay, which one has their nav values. So that's about now values, how do we deal with them, okay? And the next one is discuss the operations with data frame, okay? So there are some method that comes with data frame, like the mean, is it? You want to find the mean value, is it? And this over here, we didn't specify which axis, is it? And if you take a look at the result for the DF, is it? So what it does, the mean, it's adds all of the rows for the specific column, is it? And then divide by the number of items, is it? So that's why we have the result of the mean of each column, okay? So it does the mean calculation on dimension 1, dimension 0, as the first dimension, because we didn't specify, so that's by default. And you can also specify, is it, which axis you want to do the mean calculation, is it? Then in this case, so it to specify, I'm going to use the second dimension, is it? Second dimension, then did you see the result? What we get is each row has a mean value. So it does the mean over all of the column, okay? You get the mean value for each row, okay? So we just needed to be careful about which dimension, okay, which axis you want to do the calculation. And what next is show further operations, okay, further operations. So let's see. Over here, we have the series, so this is the series. And the index is the dates, okay? And so nothing new here. It's supposed to start at 1.0, is it? It's supposed to, if we cut off here, is it 2013, January 1st, should have value 1, is it? But after it, did you see we call shift 2, is it? So that's how the 1.0 goes to January the 3rd. Okay, so you can also call shift, okay? So shift, then it will shift all of the values with a specified gap, basically, okay, or offset, okay? And then next, let's see. So over here, this is our data frame, is it? And this is the series, is it series we just, and it also specifies the axis, is it? And it does what? It does subtraction, okay? The subtraction is along what? Here it said along axis, not along column, okay? Not along column. So with the original value, is it original value? Then what it's going to do, it's going to subtract, is it? The value from this series, is it? From this series. That's how we come with this result, okay? So over here, the purpose just to show you can also specify the axis with index or column, okay? And then what next to show is we can also, this is also quite useful, okay? The apply operation, okay? And within it, then you can specify what kind of operation you want to apply, okay? You want to apply. So you can also define your own Python function, is it? And then you plug it in, okay? Over here, what it does is this is NumPy, this is cumulative summation operation. Okay, summation operation. And because we didn't specify the axis, is it? We didn't specify the axis. So by default, it should be the first dimension, is it? So what over here it does the cumulative calculation. Okay, cumulative calculation. And then let's see. So that will help better, okay? So that df is our original, data frame that we have A, B, C, D, F, that, and we have the date time as our first dimensions index label, is it index label? And then you apply what a kind of operation? We apply the cumulative summation. Is it a cumulative summation? So cumulative summation, so it's, and because we didn't specify the axis, is it? So by default, it's the first dimension, is it? So first dimension is along the rows, is it? So it's going to do it. The easiest way to see is column D. Is it column D? Initially, it's all 5, is it? But because it's do cumulative summation, so first one 5, not to change. Is it? Then it's going to add 5. Is it to add the second 5? So that's how this, it's changed to 10. Is it? Then you're going to add another 5. Is it? So each time you add the corresponding value. Is it? So that's cumulative. And if we take a look, the same thing. The next one, this part, is it? So 1 plus 2 is 3. That's how you come 3, is it? And then 3 plus what? 3 plus 3, another 3. That's how we have this 6, is it? And then 6 plus 4, is it? That's how we come 10, is it? That's called a cumulative summation, okay? And you can also define your own method, is it? Your own function, is it? And then you can call this apply. This is quite useful, okay? Very, very convenient. So just keep this in mind. And over here, it shows again, is it? We can call apply, is it? And you see within it, you just apply. What is this? Do you still remember what is this? Anyone still remember?
It's a lambda function.
Yeah, it's a lambda expression. It's a lambda function. Okay, so it's quite convenient. Is it? So over here we see, is it? This is a user-defined function. Is it? And over here it's apply on what? Because we didn't specify. Is it? The axis, so it's by default, it's first dimension, is it? And first dimension is going to find the maximum and minimum value, is it? And then do the subtraction, is it? That's how the result, if you take a look, we have the individual value, is it? For each column, because you find the maximum from all of the column A, is it? But for different date. And same thing for minimum, is it? For all of the dates, you find the minimum, and then you do subtraction, is it? So that's why for each column, you're going to have a result for this DF apply, okay? And what the next one is shows how do we do histogram, is it? So here we have this series, is some random number, and it has 10 numbers, is it? And then we just do value count, is it? Value count. So how many 1 you have, how many 2 you have, like something like this, is it? So over here it shows, okay, 5, it has 4, so all kinds of the values. Okay, so this is a histogram. And then let's see, string method. Yeah. Okay, so string method. So we have this series. Okay, so this series is a string. That it's a string, and over here the nice thing for the pandas is it, if you want to do something on this series, did you see, you don't need a loop, is it? We can just call this s dot string, and then you just call lower. Then it will convert each of this to lowercase, is it? So all of this are lowercase, okay? And what next one shows? What next one shows is here we have a data, we have a dictionary. Is it, this data is a dictionary. And previously we learned is that we can convert dictionary to data frame. Is it? So we call PD data frame and plug in the dictionary. Is it? And over here you drop a missing value. Okay, so nothing new here. So next, let's see. So here, so based on what we get here, is it? So name is going to be a column, age is going to be a column, and the address is going to be a column, is it? And then under it, you have Jade, Prince, something like this, is it? And the address here is Nap, Kansas. Is it something Alberni? Is it Canada? Something like this, is it? So over here, we care about is this address column. Is it? Address column, what are we going to do? We are going to do split. Is it because it's a string? Is it? We're going to split. Split based use what delimiter? Using A as a delimiter. Because if we don't specify to use space, is it? So it uses A to do delimiter. So if it has A, then it's going to do delimiter as a separating split. And how many it's going to have? It's only going to take one. Okay, so maximum split into one, not all of the items splitted. So you can also specify how many you want to take from the split. Okay. So that's why you see for the first one, definitely you just take N, is it? Second one, you only take K, is it? And third one is Albert, is it? The first one is C, is it? And all of the remaining are dropped. And you reassign it to the address column, is it? So that's the information, okay? And then next, let's see. What did we do here? So here, here we have the address column, is it? Address column, and then we have the copy, is it? So we copy that column and make it a new series, is it? Make a new series. And what we do here is for the name column, is it? A name column, what do? We do concatenation, is it? We concatenation with what? With, we concatenate it to the new, is it? To that new. That new is the address field, is it? Address field. And concatenate it with what? So this is the thing we want to do the concatenation, is it? Add a comma. So the name field, did you see it's updated with the original name plus comma and the address field? Is it what we get here? Is it? But plus the comma, is it? So that's what we did here, okay? And then next, let's see. So next is we are going to do the CSV file, is it? So we read the MBA CSV file. And what we are going to do some change is the age field. Is it age field? Age field, we are going to replace a specific value 25.0 with a string 25. That's, then you reassign it. So the age field, and only 25.0 is going to be updated, okay? All of the other values going to be remain the same. It's going to be changed to 25, okay? Then next, let's see, over here, if you take a look. So this is a comparison, is it? So for age column, is it? You want to know if it's 25, is it? So this will generate a Boolean Boolean series of data. Is it a Boolean series of data? And then did you see over here? That's what we can do is we can do the where. We can use where and apply the Boolean condition. Apply the Boolean condition. The Boolean condition was this filter. As it is this filter. And we apply this, and then we can drop. So if it fits this, is it, and you can apply it to drop NA, okay? So drop the net values. So that's what we can also apply where, okay, to do filtering, and the result is showing us here, okay? So you do some cleaning work. Okay, then next, let's see. What's the next? Here we have a series S, is it? S is A1, B2, C3, is it? And then let's see, so here we get the string. And for the string, we do some extraction work, okay? And this R represent raw, is it raw? And in this, for this extraction, what we are going to pick is, here it lists the letter you're going to pick, okay? So it's either A or B, is it? So it only has these two options you're going to pick. And the following by what? Following by a number. So /D means an integer number. An integer number, okay, so it's a /D. So that's you're going to extract out, okay, extract out. So the result shows us, it looks like this, is it? You extract from that series, is it single letter, is it? And the corresponding digit, is it? Yeah, so that's what this part means. Okay, then what next one try to show is the regular expression. Okay, so it's not our focus here, but if you are interested, Python regular expression is also quite useful. So regular expression and very efficient. Okay, so here we just show a couple of. Okay, so what over here is to try to use the regular expression to do search. Okay, to do search. And the search for what in this case? So the first is, it's a dot. A dot represents a single letter. And then asterisk in Python, we said it means repeat, is it? So this means if the string pattern follows some single letter and repeat that pattern, is it? Then I'm going to find it. So then that's meet my definition, is it? Then I'm going to give it a name called name. So that's the first search, okay? That's what this question mark and P means. So it says allows one to refer to the matched string through its name so that later on I can refer it, okay? I can refer it. And the second search, for my second search, the second search is the same thing. This is a pattern defined. It's a letter and it repeat a number of times. So this is the second one. So you see over here, this is a string we are going to do the search. Is it? It has two words because it's separated by the space. So the first one, it matches this, is it? So then you're going to give this match a name called name. The second one, it also matches, is it? You're going to give it a name called phone, is it? Called phone. So that's what this question mark and the P mean, okay? And then you are going to do group, okay? You're going to do group. So here group is whatever you find from those matching, okay, from those matching. So over here under the name one, which one we found? We found John. Is it? So that's through this name, then you get the result. Okay, that's the purpose of this name and the phone, is it? Okay, so that's regarding this part of regular expression. And then let's take a look at the next one. The next one is we're going to do extract. As previously we already see the extract, okay? And for this extract, what we are going to extract? We are going to extract still the same thing, is it? We are going to follow that question mark P, is it? And the first is the letter, you define it through with what? With this AB, is it? With this AB. And then the second, if it's followed by the digit, is it? You define it by digit, is it? So this you gave the named group, is it? So that's what we have. And then here we show the A part, is it? That's what it shows here, is it? For the extraction, is it? And for its index, here it gives its index. Gives its index, is it? And its column, is it? The column is then letter and digit, because here we specify letter and digit, is it? Letter and digit. Okay, so this is regarding the regular expression. Okay, just some basic discussion. And next, let's see how do we merge, concatenate, or join multiple data frame together. Okay, because in the real world, you may have one data set from this source, another data set from another source, is it? When we do machine learning, and then you want to combine them together, is it? When you do machine, to get one single data frame. So how do we do that? So let's take a look. Okay, so it's either merge, concatenate, or join. Okay, so here we have a data frame, 10 row and 4 column. Okay, 10 row, 4 column. And then over here, this one, so we do the slicing, is it? From this original data frame, is it? From the original data frame. So you do slicing, in this case, you slicing the first 2, is it? And then from the 6 to the 7, is it? And then of the remaining, is it? With all of this, and then if you call concat method, is it? And you plug in with this all of those segments, is it? And let's see what we will have. Okay, then you can see you will have the first 2, is it? And then next is from 5 to 6, is it? And all of the remaining, is it? So the original you have 10, is it? Now you split them and then you reorganize them, is it? So you can use a concatenate, okay? So this is how the concatenate works. And then next, let's see. Okay, let's see the dictionary. Okay, for the dictionary, this is a dictionary. That one is a name, age, address, qualification. Second one is also a dictionary, is it? And here we have a data frame, is it? The data frame defines with so DF is from data 1, is it? Data 1. And then we specify the index, is it? For the second data 2, is it? And we also specify the index, is it? And this is second data frame, is it? And here we print. So this part is pretty straightforward. Just get 2 data frame with 2 dictionary, okay? So here we have 2 data frame and 2 dictionary, okay? And then next, let's see. The interesting part is the next part. That's what we interest here, okay? So here we call the concatenate concatenate function is that of pandas. And then you specify these 2 data frames, the df and the df1. And then the dimension, on which dimension we are going to do the concatenation. And over here is saying the join manner. So how are we, the approach is that we do the join. So over here it says inner join. Is it inner join? So inner join means you're going to look for, we have the same, on the second dimension, is it based on second dimension, we have the, so over here we are going to basically expand, is it the second dimension? Okay, the second, and the join manner is the inner way. Inner means you look for the commons from both df and df1. So you look for common rows basically, okay, with the same index, okay, from both of these 2 data frame. And then you're going to expand on the second dimension, and using which manner? Using the common index. So let's take a look. The common, is it common index? So here you have 2, 3, the index label 2 and 3, is it? So this is for the inner join, is it inner join? So only these 2 have cross section, is it overlap with each other? So we are going to pick all of those, is it all of those, is it? And then what? We are going to expand, is it expand? So if you take a look at the result, you will see name, age, address, qualification, and mobile number. That's from the first data frame. The second data frame is from name, age, address, qualification, and salary, is it salary? So that's from the second data frame. And then we combine both of them together, is it? So that's the result. That's for concatenation, is it? We do the inner join and you specify how you expand, okay? So this is the second discussion about concatenation. And then let's take a look. The furthermore concatenation, is it? And over here we do concatenation, is it? And here we specify expand the second dimension. But here we didn't specify how are we going to join. So then by default it's union, okay, if you don't specify, okay, union. So you will see the result is expanded, is it include all of the records, is it from both data frame, is it? And also the column is also expanded, okay? And you can also specify if you want to sorting or not, okay? So that's regarding this concatenation. And then the next one, concatenation, is it? For this concatenation, it's still on the same, and you're going to expand on the second dimension, is it? So number of columns. Here it also say the join axis. So you're going to based on which axis we are going to join, is it? And here says we are going to join on the first data frame's index to do the join. So you are only going to pick from the first data frame. So this is the first data frame, okay? Data frames index, we are only going to pick from those. So if the second data frame, if it doesn't have any of this index label, then none of the item is going to be joined. But if it has overlap, is it, then it's going to be joined. That's how we have of this result, is it? And 0 and 1, if you take a look, the first part, is it? This part is from DF, is it? But regarding all of this part from DF1, because it doesn't have the value, that's why everything is net, is it? It's net. Okay, so that's regarding this concatenation. Okay, concatenation. And I think we just stop here today. Okay, stop concatenation, and tomorrow we can finish everything. Okay, discuss join and other operation. Okay, so I'm going to stop